Welcome back my friends, a very good morning, good afternoon, good evening to all of you. I am Raghunandan Sengupta from the IME department, IIT Kanpur, and as you know that we are interacting for the course Total Quality Management part 1, obviously there would be part 2 later on, and this is the 18th lecture we are having. So, as we were discussing the concept of acceptance sampling, two-stage sampling, sequential sampling, and depending on the values of D1, D2 or C or N, whatever it is, we will make a plan that whether we will accept that lot, reject that lot. And before that we did discuss in a decent amount of details, and for all information please read the Montgomery book if at all you can get a hand to that. That is an excellent book in the area of statistical quality and to get an idea. It is a little bit on the upper side, but it is a very good book. It will take time, go through the problems, try to understand that, and you will be able to implement many of the statistical process control, quality control issues in practical sense. So, when we are discussing the acceptance sampling in this two-stage, multi-stage, so obviously we discuss the concept of total cost, and that will come into the picture later on. So, let us continue our overall analysis and interaction for acceptance sampling and the different ways how it can be done. So, let us start with the average sample size. So, basically I want to find out the average sample size which is needed in order to basically meet some criteria already set laid down criteria which you want to study. And obviously it would mean that intuitively more the number of sample size, better the prediction, better the forecasting, better the way you are trying to study. But on the other side, the flip side is that there would be a cost involved. So, you have to basically maintain a balance such that efficiency, robustness of the method, trying to predict or forecast the actual parameter value what you want to find out from the sample given you want to study the population. So, those things should be kept in mind as well as along the cost structure. So, average sample size which is ASN. In double sampling, the size of the sample selected depends on whether or not the second sampling is necessary, which is true, because if I pick up a small size n of sample from the lot, and if C is fixed, which is the number of defects which is permissible, and at D1 the number of actual defects is less than C, obviously you accept that lot. If it is not, then you go for the second stage, and in the second stage the next lot which you find out, which is say for example D2 minus D1. So, obviously you had picked up D1 in the first lot, then you pick up D2 minus D1 in the second lot. So, if D2 total, which is the total number of such defects in the first lot and the second lot, is less than equal to some stipulated number, you will either accept or reject or basically take decisions accordingly. So, 3 stage would be done accordingly, 4 stage would be done accordingly. So, they would be algorithms, very set of patterns of rules which you will follow. So, obviously it will mean that you will only sample in the second lot considering it is a double sampling, provided the first criteria is not met. If it is met, obviously you will stop. So, that is known as the stopping criteria. So, the probability of drawing a second sample varies with the fractional defective which is coming in the lot. So, obviously if the probability is very high, then the probability of drawing a second sample would increase, because you have to pick up in order to basically be aware whether the whole lot has defects or not. If the actual proportions in the real numbers P is much less, then the probability of picking up the second lot obviously diminishes and becomes very small, which means you would not require to pick up the second sample. When complete inspection of a second sample, the average sample size is basic in the double sampling is equal to these, which is the size of the first sample which you picked up, multiply the probability that there would be only one sample, because in two cases there can be two conditions. I take the first sample with some probability, and also the case that I will have to go for the second sample with some probability. If it is a 3 stage, obviously it will become first, second, then once you reach the second it will be second, third. If it is the fourth, then you will basically go third and fourth and so on and so forth. So, obviously there technically would be two outcomes from any stage. So, if it is you have to go for the second, it means that you have reached the first the decision point based on which you have considered the first sample, and then only make a decision to go for the second. Once you reach the decision point for the second, then only you decide on the outcome whether you should go for the third. When you reach the third, the decision point, then you make a the analysis whether you should go for the fourth, and so on and so forth. So, for the double sampling, the sample size is equal to the size of the first sample in the probability that there would be only one sample, plus the size of the combined sample, which means as we are trying to understand D2, the total number of defects, obviously that sample size would now be initially N1, later N2, which is the combined sample size which you have for two samples, multiplied by the probability that a second sample would basically be necessary. If it is a third one, obviously it will depend on the combined size, and the corresponding probabilities would be brought into the picture accordingly. So, therefore, the general formula is, if you see the last value, let me point it out. If you see the last case, so this term which you have, which is I am highlighting, is the sample size N1, if you remember, for the first sample, multiplied by the corresponding probability which is for the first stage, hence the suffix 1. So, the 1 basically denotes the first stage set of observations, whether the probability, whether the number of defects, or whether C which is allowed. C can also change for your kind information, or whether the probability. So, the suffix would basically denote at which stage. And in the second case, when we use the second probability, is the sum of these. So, this is technically the total value which you have, total sample size, multiplied by the corresponding probability that the second sample is needed. So, this is 1 minus P1, because in case if it is P1 is already taken care for the first stage, then obviously 1 minus P is there for the second stage. It is basically like a binomial concept, where there are two outcomes, and then you proceed accordingly, and the probabilities would be calculated accordingly. So, once you do that, it is the probability comes out, the overall average sample size comes out to be N1 plus N2 multiplied by 1 minus P1. So, where P1 is the probability of making a decision on the first sample, which is basically like this. Probability of lot is accepted on the first sample, plus lot is rejected in the first sample. So, there would be two costs. Cost would be coming that the first is accepted, one sample size from there, another is that it will be rejected, the first lot would be rejected, hence the sample size would be coming from there also. So, I am trying to find a corresponding average. Now, consider very intuitively, the averages would be basically found out, like say for example, if I want to find out the average and I pick up a set of observations, and consider the very simple case where you are rolling a die, the face values are 1 to 6, and the corresponding probabilities, considering is a unbiased die, are all 1 by 6. So, when I want to find out the average, what I will do? I multiply by the realized value, which is 1, 2, 3, 4, 5, 6, whatever it is, multiplied by the corresponding probability, which is for which case it is all 1 by 6, because this is a uniform discrete distribution case. Now, consider this case. So, I will come to that example which I am explaining on the slide later on, but consider a second case for the example of rolling the die. Now, the faces are not 1 to 6, but they are now 1, 1. So, that means number 1 appears twice, other numbers are 2, 3, 4, 5. So, all the 6 faces are there available to you. Now, it is also an unbiased die. Now, if I tell you to find out the averages, what you will do? In the initial case, you multiplied the realized value multiplied by its corresponding probability. There now, you will basically multiply the realized value into its corresponding probability. Only the difference is that in this case, number 1 is appearing twice. So, the expected value or the average value would be 1 into 2 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6. So, the 6 number is not there, because 6 has been replaced by number 1, which is appearing 2 number of times. So, if you follow this logic and if you see this formula is exactly the same, you have the total number of observations which is in the sample size, which is given by n suffix whatever it is 1, 2, 3, 4 depending on that, multiplied by the corresponding probabilities. So, in this case you had taken the sample size n1 with the corresponding probability of p1, and in the second instance you will pick up a whole lot, because you have to consider the whole lot as such. It will be n plus 1, n1 plus n2 combined, multiplied by the corresponding probability that will go for the second lot's set of observations, where the probabilities are respectively p1 for the first lot, 1 minus p1 for the second lot. So, if you use this simile with the example which I gave for rolling the die and trying to find out the average, and with this case it will make sense to you how we find out the average sample size or sample number. Now, considering the average sample number further, so where again I am mentioning that the diagrams are all from Montgomery, it is figure 15.15, which shows the average sample number curves for single and double sampling. So, single sampling means you pick up only a lot, take a decision accordingly. In double sampling is that you pick up one lot, take a decision, and if it is met then you stop, if it is not met then you go to the second stage and then basically make the final decision. So, in this case you measure the average sample numbers along the y axis and the lot fraction defective, which is the p value, depending on the sample which you have collected on the x axis. And if you have a single sampling, it is a straight line obviously, because depending on your lot size perfect defective, the average sample size would remain depending on the sample lot which you are picking and the probabilities you are picking, the probability is not changing. So, if you pick up n1, it remains n1 and you make a decision, because there the probabilities does not matter, because only you will pick up 1 with probability 1. So, if you pick up n2, it remains at n2, if you pick up n3, it remains at n3. So, considering the horizontal line which you have drawn, which is a little bit less than 90 if you see this figure. So, it remains at the same level depending on single sampling which you have done for different set of observations. So, it remains at the same level, but in case say for example, you are doing complete double sampling cases, so obviously the probabilities and the sample size would differ, which would have an effect how the curves looks like. So, the average sample size depending on complete inspection and curtailed inspection would definitely be not a straight line, but curve depending on n1 and the corresponding probabilities, which is p1 in the first case, and obviously in the second case when you pick up the second lot, it is 1 minus p1. Now, when I want to find out the average sample size with curtailment, that means I have to basically cost structures are there, I need to basically minimize the cost. Then the formulas would be given that in the first case I pick up n1, and in the second case I would pick up a small certain sample which would basically depend on what are the set of observations which I am doing. Now, I will like to a little bit deviate from that and basically tell you the concept of, say for example, the double sampling or the triple sampling or the stage wise sampling which you do, or the sequential sampling plans which you do. Now, why this is important? Consider I am not actually deviating from TQM, but basically I am trying to give you an example. Consider that you are trying to do a marketing survey, and marketing survey needs a lot of costs. So, if you are a company executive or company vice president and money is not a factor for you, so obviously you will invest all your money, whatever the quantum is, to do a marketing survey and conduct your studies accordingly. But now consider money is important and that has to basically be used judiciously, which means that the number of samples which you can take to predict or forecast or find out the actual population characteristics would definitely be based on the fact that the overall information which we will be getting from a smaller set of samples, considering that money is limited, has to be done judiciously. So, what technically would do is that, very simply think about the plan. You would basically pick up some set of observations, study the sample characteristics. So, now what you will do is that you will have some stopping criteria. Stopping criteria what I am using for the first time, but it very simply means that you have some rule based on which you will proceed. So, those rules are already found out from theoretical results, As it is not a part and parcel of this course, let us not discuss that, but that can be found out depending on the type of distribution which you have, what type of example you are doing. So, you have some stopping criteria, some stopping rules. So, what you do is that you pick up a small sample n1 consider, and you test whether the stopping criteria is met. If it is met, you stop your experiment, report that sample size as the best sample size depending on the stopping criteria, and use that to study and find out the sample characteristics which will mimic the population characteristic to the maximum possible extent. It is not possible to make them exact, but it will give you some error, but those errors are the one which you want to minimize or make it as small as possible, based on which you are getting the stopping criteria or stopping rule. Now, if the stopping criteria is not met by n1 set of observations which you have, you will take, say for example, in the next stage some extra number of observation which is n2. So, what you will now have a whole set of observation which is now n1 plus n2. Based on n1 and n2, you find out the sample characteristics, check with the stopping criteria. If it is met, report that sample size of n1 plus n2 as your actual study, and do the set of calculations accordingly. If the stopping criteria is not met, again you take say for example, n3 number of observations. Then again you check the sample characteristics based on the sample where the size is now n1 plus n2 plus n3. You check, if it is met, stop, if not, you proceed accordingly, which means that the set of observations which you are taking are being basically tempered to the fact that how good or bad they are with respect to the stopping criteria, but also at the other end you are trying to balance your total cost accordingly. So, if you follow this small concept which I just mentioned, then you can basically try to be able to reduce your overall cost. So, the cost can have different implications, it can be risk, it can be total cost for sampling, different things could be there. Based on that, if you find out the average sample size with curtailment, you will get this formula. I am not going to the actual details of this, you will find out the actual formula such that you can find out that based on the curtailment, whether it is for 2 stage or 3 stage or 4 stage, you can find out the average sample numbers accordingly. But remember, always it is basically to study the average samples numbers depending on what number of observations you took in the first lot, then in the second lot, depending on the criteria have been met or not, and there you are proceeding. So, if you find out in this, so what you actually have is basically the probabilities that given the sample size n1 and n2, you can basically proceed and find out the probabilities and multiply them with the corresponding sample observations and do it the calculations likewise. Now, double sampling plan, as I just mentioned, the example was for the single sampling plan, then I just mentioned very briefly for the sequential sampling plan. So, let us go into the double sampling plan in details. So, rectifying inspection and average lot inspection numbers. So, rectifying inspection means when rectifying inspection is performed with double sampling, the AOQ curve. If you remember, when we are doing the OC curves, those concepts were considered. So, I am just giving the results, you find out the AOQ values, which would basically depend on which stage you are sampling. So, the suffix which you see over P, so it can be either 1 or 2. So, depending on whether it is double sampling, whether in the first stage or the second stage. If there are more than 2 stages, 1, 2, 3, so obviously the suffix would change accordingly. So, here N1 and N2 are the total sample observations which you are taking in the first lot and the second lot accordingly, and capital N is the total size of the sample space which you have from where you are picking up the lots. So, if it is n capital N minus small n, it basically means the overall numbers which are there which are still left. So, N1 you have picked up, capital N minus N1 is the total set of observation which are left in the so called sample space or the box. Technically capital N, if it is infinite, then it would not matter, but I am just giving you an example, because in many practical cases the capital N value would definitely be very large, but it definitely is a plausible number which based on which you can do your calculation. Now, if you pick up a second lot, that means you picked up the set of observations. So, obviously that total number of set of observations in the first lot and the second lot would be subtracted from the capital N, which is the sample space. and then you will multiply each values correspondingly with the values of the probabilities and basically find out the AOQ value. Assuming that all defects have been discovered either in sampling or 100% inspection are replaced with the good one. So, once you find out the bad one, you replace. So, if you remember in the double sampling concept when we were discussing in the last class, I did mention that once you find out the defective one, you remove them and replace them with good one. So, obviously, that information would come into the picture as you are calculating the overall the AOQ values accordingly. So, the average total inspection curve would be given by the multiplication of n1 into p suffix 1 and prefix 1 and suffix a, which basically means the probabilities that the accepted numbers are some fixed value depending on whatever you think is right in the first case. Then p prefix to suffix a would basically be the corresponding probabilities in the second stage and so on and so forth. So, based on that you find out the overall the ATI, which is basically the total inspection average total inspection numbers accordingly. So, remember PA, P suffix A is basically the sum of the probabilities in first stage and second stage, which is the probability of the final lot acceptance, and that the acceptance probability depends on the level of the lot or the process quality, which is P. So, the formulas which are given are just the end results. Please, if required, refer the book, because the overall concept which you are trying to follow is very vast. So, you will try to basically not skip, but try to not go into the details of too much of details, just give the final formulas based on which you can basically solve the problems accordingly. Now, we come to the multi-stage sampling plan. So, a multi-stage sampling plan is an extension of the double, which can go into the triple and so on and so forth. In that, more than 2 samples can be required to be picked up from a lot to pass on your judgment. An example of a multi-sampling plan with 5 stages are given as in front of you in table 15.3.2. If you remember, I just mentioned about few minutes back about the sequential sampling plan, that if you are taking set of observation, trying to find out the characteristics of the sample, check with the stopping criteria, and then either proceed or not proceed depending on what the results are. This is basically that only explained in much detail. So, you take out 20 set of observation in the first, your accepted numbers are given and the rejections numbers are given. So, you pick up 20, check, if it is not met you stop, if it is not met you proceed. Then you again pick up 20. So, now the overall cumulative number of observations now becomes 50. That is what I mentioned when I pick up N1 in the first lot, check the result, if it is not met then I go into the second lot, which means again I pick up N2. Now, I find out the sample characteristics based on the sample size, which is now N1 plus N2, check with the stopping criteria met, stop, it is not met, proceed. So, in the same way if you look at column 1 is exactly what it mentions. I pick up 20, then 20 and so on and so forth and proceed accordingly. So, the cumulative sample sizes are 20, 40, 60, 80, 100. The accepted numbers are given depending on the problem and the rejections numbers are given. This plan will operate as follows. Let me read it, you will understand. If at the completion of any stage of the sampling, the number of defect items is less than or equal to the acceptance number. So, the acceptance number and the rejections number are based on some set criteria which is already been decided, which is what I have been mentioning as the stopping criteria. So, let us continue reading it. The defected items is less than or equal to the acceptance number, the lot is accepted. If during any stage the number of defective items equals or exceeds the rejection number, then the lot is rejected. So, you reject or accept depending on that. So, here if you see that I did mention that if the stopping criteria is met, you stop, stopping criteria not met, you proceed, is the same thing. Stopping criteria means basically the difference or the rejections and the acceptance number. In this case, obviously in other case it would be fine tuned based on what type of calculations which you have done for the stopping criteria. So, as I was reading, the multiple sampling procedure continues until the 5th sample is taken, at which time a lot disposition decision has to be made. The first sample is usually inspected 100% number of times, although subsequent samples are usually subject to curtailment and you make a decisions accordingly. Sequential sampling plan. Sequential sampling is an extension of the double sampling and the multiple sampling concept in more details. In sequential sampling, we take a sequence of observations or set of samples from a lot and allow the numbers to be determined entirely by the results of the sampling plan process. So, if you remember, I have been mentioning about stopping criteria, which basically a rule is there, but the results of the rule or the outcome of the rule in some mathematical sense will depend on how many number of observations I have taken previously. So, this is what it is mentioned. The number of samples to be determined is determined by the results of the sampling process. In practice, the sequential sampling can theoretically continue till infinite time. So, you may not stop until the lot is inspected 100% number of times. In practice, sequential sampling plans are usually truncated after the number of inspection is equal to 3 or times the number of the would be to have been inspected using a correction corresponding single sampling plan. Technically, they can go to infinite. So, you check, stop, if it is met, not stop, you continue. So, what is mentioned here is on the practical framework, but in the theoretical framework it can go till infinity. If the sample size selected at each stage is greater than 1, the process is usually called a group sequential sampling. If the sample size inspected at each one is 1, then it is called a sequential sampling plan. So, let me explain it in more details. I take a set of observation which is N1. Now, when I mention the last sentence mentions is sequential sampling, which technically is purely sequential sampling, is what? I take one extra observation. So, now my sample size is now N1 plus 1. I check the stopping criteria based on the sample size of N1 plus 1. If it is met, stop and report that N1 plus 1 as the sample size and finish my task. If it is not met, then I again take another extra observations. Now, my total number of observations is N1 plus 1 plus 1. That means, plus 1, the first plus 1 was from the last previous stage. Now, I take another observation. So, now it is N1 plus 2, check the criteria, met, stop, not met, go to the third stage where I take N1 plus 1 has already been taken, I take an extra plus 1. So, it is basically N1 plus 3. Now, in the other cases which is more mentioned as group sequential sampling plan is basically known as batches. So, it means I can take N1, then take not 1, but say for example, I take N2 where N2 technically can be less than N1. So, I take batches. Then in the third stage I take N3 which is also less than N2 now, and I proceed accordingly and finish my task. So, in general it is seen that technically in sequential sampling plan, if there are restrictions on some stopping criteria or some total cost and all these factors are there, in general the efficiency and the robustness of the sampling procedures are better than the fixed sampling plan, where the fixed sampling plan in the sample is already predetermined beforehand in general, and also the overall efficiency of the models for sequential sampling plan are much better. So, with this I will end the 18th lecture and continue a discussion of sampling and total quality management further on starting from the 19th and so on and so forth. Have a nice day. Thank you very much.